Hello, Gretchen?
Yes, sir.
Okay.
We'll proceed na to, sir.
You can start now.
Sir, can you see my slide, sir?
Yes.
So,
Go.
good evening, Sir Job. Good evening, classmates. So, I will be reporting tonight a special case of a transportation problem, which is called a transshipment problem. So, this is the outline of my presentation this evening. First, I will be giving a brief overview of what a transshipment problem is by simply comparing what a transportation problem that we already know and what a transshipment problem is. Then followed by a transshipment model, which I got from YouTube. And I will be presenting next the transshipment problem that I made following the model in the second part of my presentation. And finally, I will be presenting the sensitivity analysis of the results of my transshipment problem. So let me now proceed to the first part of my report, which is the overview of a transshipment problem. So I got this definition from the book of Albright and Winston entitled Business Analytics, Data Analysis and Decision Making. So here in this definition, it has been mentioned what a transportation problem is and a transshipment problem. So a transportation problem allows only shipments that go directly from a supply point to a demand point. So we already know about this. This is our previous lesson. But in many situations, in real life situations, usually shipments are allowed between supply points or between demand points. And this is not one of the characteristics of a transportation problem. There is also another case wherein there may also be some points called the transshipment points. What are transshipment points? These are points where goods can be transshipped on their journey from a supply point to a demand point. So shipping problems with any or all of these characteristics are called the transshipment problems. So to help us understand better the transportation problem and the transshipment problem, I will be giving illustrations. So first, on the left side of my screen is an illustration of a transportation problem. So again, by definition, it's a shipment that go directly from sources to destination. The second illustration is an example of a transshipment problem. So there may be or shipments are allowed between sources. So as you can see, there is a red arrow from source S1 to source S2. Um, shipments are also allowed between the destination points. So as you can see, there is a shipment from destination D3 to destination D1. And another illustration of a transshipment problem is when there are transshipment points. So these are transshipment points. These are two transshipment points in this model. So shipments come from sources that go through transshipment points before it goes to its final destination, which is the uh, demand points. So let me now go to the second part of my report, which is the transshipment model. So I got a video from YouTube. It's entitled "The Transshipment Problem in Decision Making" by Ahmad Bazi. So I will be playing the first part of the video only, wherein um, Professor Ahmad discussed about how to model a problem or convert a transshipment problem into a linear programming problem. I will no longer include the second part wherein the professor used MATLAB in solving the problem. Since in my presentation, I will be using the 6PAP software and the Excel software.
So the transshipment problem is a type of transportation problem.
Sir Job, can you hear the audio of my video, sir?
Yes, yes.
They've got,
Loud and clear.
they've got the destination and some intermediate node, let's call it I. It is a type of transportation problem where your goal is to ship from S to D in as cheap or as fast as possible. So you're trying to optimize a certain criterion, let's say time or cost. So the cost from going from S to D by passing through I. So this arises a lot in decision making, operation research, and where you have to pass through an intermediate source I. I'm going to give you a very nice example. You're going to fully understand the transshipment problem through a simple example. So this example is going to contain some, let's say I've got some plants or a certain industry. So I've got 3 plants. Those plants, they transport goods to, let's say, a warehouse or multiple warehouses. They've got 2 warehouses. So those companies or industries, they have a deal with some warehouses. They transport their goods to the warehouses. So they're supplying. And the term supply here is really important. Now, in turn, the warehouses have to supply directly to dealers, or let's call them, in this case, customers. Let's say I've got 4 customers, and the warehouses supply the customers upon demand. And demand is another key term here. So we've got supply and demand going on in this transshipment problem. The industry is not going to come and sell you, the dealer or the customer, directly. No, it transfers to warehouses, and then the warehouses will supply you, the customer. So what we have right here is just, you can see it as a multi-transportation problem that is seen as one network or one system, right? Because, plant to warehouse is one transportation problem, and warehouse to customers is another one. But you can't just optimize each one separately. No, you have to take both as a batch, as one problem. Note that you can also extend the layers, so customers could also sell to other customers or to shops or so on. So this could be a multi-layer transportation problem, thus the name transshipment. So we need not to have only one layered intermediate node, right? So as in the transportation problem, each path comes with a cost, right? So let's say for that, the cost from going to, plant 1 to warehouse 1 is 4. From going to plant 1 to warehouse 2 is 7, and so on. I'll just throw in some random values. Likewise, the warehouse has to pay for each path taken to arrive as certain customs. So for that, let's say this is 6, this is 4, this is 8, this is 4, this is 3. So let's say I've got all those costs, right? And let's put them in a table, right? It looks way better in a table. Right, so we have just calculated the costs we have at each transportation. The way we can read this is the cost from the plant to the warehouse. So this data right here to the warehouse. So the cost going from, let's say, plant 2 to warehouse 1 is 8. So 2 to 1 is 8. Cost going from plant 3 to warehouse 2 is 6. 3 to 2 is 6. And likewise, if we look at the second table, we've got the cost going from a warehouse to a customer. So let's say the cost from going to warehouse 2 to customer 4 is 7. 2 to 4 is 7, right? Now, what is the total cost of this, say, system? It's the sum Cij Xij, where Cij is the cost, which is extracted from this table, from plant I to warehouse J, whereas Xij is the number of units that I am transporting. So you can understand it that way. One Xij will cost you Cij, right? So you can put it that way. Now we've got an I going from 1 to 3, because we've got 3 plants, and J going from 1 to 2. Now we've got to add the other cost as well. The cost going from the warehouse to the customer. So we've also got a double sum. It's the same thing. I'm just going to change the notation a bit. We've got Cij prime and Yij. Okay, so my I is going from 1 to 2 because I've got two warehouses. So Cij prime is the cost per unit from going from warehouse I to customer J. Likewise, Yij is the number of units being transported from warehouse I to customer J. So for that, my J will go from 1 to 4. Right, so in case you want to expand this, you could just copy paste the values right here. So I just replaced the values and I just colored the cost from going, the total cost from going from the warehouse to the customers in blue. So this summation right here is nothing other than this part, right? And this summation right here is this part, okay? I'll just remove the markers because it's making stuff look really weird. Right, so this is the total cost from transporting goods from the source to the destination, from the plants to the customers. Now, as one might suspect, if we leave the problem as such, unconstrained, right, no constraints whatsoever, and your objective is obviously to minimize this total cost with respect to my x's and y's, the solution is trivial, right? You know, it's just all zeros, so everything is zero. That means I'm not going to transport any goods, right? Because that's what you have. You want to minimize the total cost? Well, there you go. Don't do anything. Don't transport anything. But life doesn't work that way. So to model reality, we're going to have to say some stuff about the plants and the customers. So let's say the plants have a certain capacity, right? Plant 1 could not produce more than 450 units, for example, 450 units. Plant 2 couldn't produce more than 600 units, and Plant 3 couldn't produce more than 380 units, right? So I've just added this column right here. Each plant has a certain capacity. And likewise, let's say customers don't need, there's a certain limit on their demands, right? So the plants are supplying with a limited capacity, and customers are demanding under a limited threshold. Let's say the customer 1 is happy with 300 units of goods. Customer 2 is also happy with 300 units, customer 3 as well, and customer 4 is a bit greedy. He's got more clients, so he's happy with 400. And, you know, customers are always right. Those should be modeled as equality constraints. The customer doesn't need less or is not happy with less, and, you know, he doesn't need more. He needs the exact amount, 300, 300, 300, and 400, okay? Whereas plants, you know, you can be flexible with plants. You can model plants produce at most 450. Plant 1 produces at most 450 goods. Plant 2 produces at most 600 goods. And Plant 3 produces at most 380 goods. So let's add this data to the customer table. So this is how the tables look like right now. Let's translate capacity, first of all, into constraints. The first constraint we can put on Plant 1 is that the total number of goods produced by this plant should be less than or equal to 450. Now the total number of units of good at Plant 1 is simply just x11 plus x12, right? So x11 plus x12 should be less than 450. Likewise, for Plant 2, x21 plus x22 should be less than 600. Same thing goes for Plant 3, x31 plus x32 is less than 380. And this should limit the capacity of the plants. Likewise, if we go to the customer table, we can see that the total number of goods served to customer 1 should be equal to 300. So for that, let's go ahead and say Y11, which is the total number of goods transported from warehouse 1 to customer 1, and Y21 plus Y21, this is the total number of goods given to customer 1, should be equal to 300. Let's go on to customer 2, customer 3, and customer 4. So I don't like how this looks like a lot of variables double indexed. we could simply rename our variables as we wish. So I'm going to name this as, I'll name this variable as x1, this is x2, x3, x4. Notice that those x's are indexed by one number. It's not a double index, it's not a matrix. It's just, you can see the effect. Y11 could be set to x7, so that things are consecutive. This is x8, x9, and all the way down to 14, right? 14 variables up to this point. If we want to do the link right here, so this guy is x1, this is x2, this is x3, 4, 5, and 6, this is 7, this is 11, this is 8, this is 12, 9, 13, and 14, right? We can recopy everything right here. So at this point, my problem looks like this. It's not done yet. I'm just saying we can reformulate it that way. So this is how the problem looks like right now. It's not done. We're still missing a really important point right now. And it's the idea of supply and demand. So that said, all intermediate nodes should act as, you can see all the goods conserved. That said, everything that is coming in should go out. The warehouses should not lose. Ideally, they shouldn't lose any items unless the warehouse sucks or there's thieves around in the neighborhood or whatsoever reason. But ideally, warehouses should not lose goods. That statement will give two additional constraints. Each constraint is associated to a warehouse. All the goods that are going inside warehouse 1 should be given back or shipped to all the customers. Likewise, everything that came into warehouse 2 should leave warehouse 2. So everything leaving warehouse 1 is Y11 plus all the way down to Y14, right? Minus everything coming into warehouse 1 is X11, should be set to 0. Now, remember that we did some sort of mapping between Xi's and the uppercase Xij, Yij. So replacing those here, guys, X7, X8, X9, X10, and X1, X3, X5. This is X11, X12, 15, 14. And this is X2, X4, X6. Now, adding those two constraints to the problem will give me two additional constraints, right? So this is the problem we have. First of all, let's recognize that this is a linear program, right? This could be written as C transpose X, right? Those three inequality constraints could be written as AX less than B. I'm going to insert a subscript here, AI, BI, that stands for inequality. And the rest can be written as AX equal to B. I'll just insert a subscript E, standing for equality. Okay? So how do we... So the
that's only the first part of the video. What I'd like to share with you in that video is how the professor converted a transshipment problem into an LP problem. The rest, we already know what to do. We have softwares that we have been using in solving an LP problem. So to summarize the transshipment model, I'll be showing you some of the clips of the video. So this one is, there's a plant and there are demands from the customers, but before the product reaches the customers, it has to pass through transshipment points, which in this case are warehouses. And these are the costs to ship a product from, say, in the first table, from plant to the warehouses. In the second table, you can see the costs to ship the products from warehouses to customers. And the total cost is given here. It's just the product of the cost and the number of products shipped. For example, in this first term, this is the cost times the number of products shipped from plant 1 to warehouse 1 and so on. So that was already explained a while ago. And these are the constraints. This one is our objective function. The constraints are this. The first column are the constraints representing the nodes in the plants. Then in the second column are the nodes representing the customers. And these are the constraints representing the warehouses. So it was also explained how these were taken. So this is now our LP problem representing transshipment model or the transshipment problem. In the video, if you will continue watching it, the professor used the MATLAB software. So this was what he got. The optimal value or the least cost to ship the demands of the customer is 11,850 kaning part na na-highlightan. And these are the values of the excess. I tried to solve this using 6PAP. So I inputted the coefficients of the objective function and the coefficients of the constraints as well as the right-hand side of the constraints. I also got the same answer. So if you will see that, the optimal solution using MATLAB, we got 11,850, and I also got 11,850 using 6PAP. For the optimal solution or the values of the X sub i's, which are the number of products shipped from one point to another, it may be from the plant to the warehouses or to the customers. We also got the same values. So that is the model that I will be using to answer the transshipment problem that I created. So let me now present to you my example. So let me read the problem. A family owns 3 shops for linens located at Butuan City, Surigao City, and Bislig City, which requires 980, 650, and 530 linens per day respectively. Their product is imported from 2 manufacturers located at Yiwu and Guangzhou, which can produce as many as 1,080 and 1,100 linens per day respectively. Since there is no direct importation from manufacturers to Mindanao, so all importers has to pass through Manila. So these are real locations of warehouses in Luzon. So since we cannot directly purchase products from manufacturers to Mindanao, so we have to pass through warehouses. And before that will be shipped to their final destination, which are the shops in Butuan, Surigao, and Bislig. So let me continue reading. The linens are shipped first to warehouses at Malabon, Muntinlupa, and Valenzuela, and then ship them to their final destination. So the costs of shipping a linen are shown in the table. So here are the shipping costs. So from the manufacturers Yiwu and Guangzhou, as you can see in the first table, the cost to ship from Yiwu to warehouse Malabon is 12 pesos. From Yiwu to Muntinlupa is 8 pesos. From Yiwu to Valenzuela is 10 pesos. From manufacturer Guangzhou to Malabon is 10. From manufacturer Guangzhou to Muntinlupa is 12 pesos. From Guangzhou to Valenzuela is 15. And as stated in the problem, the manufacturers Yiwu and Guangzhou can produce 1,080 and 1,100 linens per day. Now in the second table, we can see the costs to ship the linens from the warehouses to the shops in Butuan, Surigao, and Bislig. So we have from Malabon to Butuan, the cost is 8 pesos. Malabon to Surigao is 10. Malabon to Bislig is 12 pesos, and so on. In the last row, you can see here the demand from the shops. So Butuan, the shop from Butuan needs 980 linens a day. Shop from Surigao needs 650 linens, and the shop from Bislig needs 530 pesos. And in addition to the constraints that were given in the video, I added some destinations or possible shipments between the shops. So we may also, or it is also possible to ship linens from Surigao to Butuan, and the cost is 3 pesos. From Bislig to Butuan, 5 pesos. Butuan to Surigao, and Surigao, Butuan. We also have possible shipments. Now, to better view this model, we will be illustrating this using a figure. So starting with the manufacturers, we have Yiwu and Guangzhou. So they can produce 1,080 and 1,100 linens. We can ship from Yiwu to warehouses Malabon, Muntinlupa, and Valenzuela. We may also ship goods from Guangzhou to the 3 warehouses. For the second table, we can also connect lines between the warehouses to the shops. So from Malabon to Butuan to Surigao and Bislig. And from the problem, the need of the shop from Butuan is 980. Surigao needs 650 and Bislig needs 530 linens. In the same manner, from the warehouse in Muntinlupa, it can also ship directly to Butuan, Surigao, and Bislig. From warehouse Valenzuela also directly to Butuan, Surigao, and Bislig. But again, as I have said, we cannot, there is no shipment from the manufacturers directly to Butuan, Surigao, Bislig. And for the last table, we added some constraints, no? Shipping from Butuan to Surigao and Surigao to Butuan. And we also have shipments from Butuan to Bislig and Bislig to Butuan. If you notice, we do not have shipments from Surigao Bislig because shipping from Surigao to Bislig simply means shipping from Surigao to Butuan, then to Bislig. In the same manner, the shipment from Bislig to Surigao is just the same as shipping from Bislig to Butuan, then Butuan to Surigao. So this now illustrates the transshipment problem that we have. So the problem now is the family wants to minimize the total cost of shipping the required linens to its shop. So now this is an example of a transshipment problem. The next thing to do is to identify the decision variables. So these decision variables are the variables that represents the number of linens shipped from one point to another. So let's start with X sub 1. Let X sub 1 be the number of linens shipped from Yiwu to Malabon. Then X sub 2 be the number of linens from Yiwu to Muntinlupa. X sub 3 from Yiwu to Valenzuela. X sub 4 from Guangzhou to Malabon, and so on. Then from X sub 7 is the number of linens from Malabon to Butuan, Malabon to Surigao, Malabon to Bislig. Then from warehouse Muntinlupa to Butuan, Surigao, and Bislig. Then X sub 13 from warehouse Valenzuela to Butuan, then Surigao, then Bislig. And the last 4 destinations or shipments is from Butuan to Surigao, X sub 16, X sub 17 for Surigao to Butuan, X sub 18 Butuan to Bislig, and X sub 19 Bislig to Butuan. So there are, this is 19. There are 19 decision variables. And as you can see in the figure, there are also 19 connections between points. Now, the next thing to do is to form our objective function. So as we already know, the objective function is the total cost of shipping the required linens from the manufacturers to the shops. So that's simply the sum of all the product of the cost and the number of linens. So for the first term, the cost to ship from Yiwu to Malabon is 12 times X sub 1, which is the number of linen. So following through, we have 8X sub 2, that's from here, then 10X sub 3, then 10 from Guangzhou to Malabon to X sub 4, then we have 12 Guangzhou to Muntinlupa, X sub 5, and so on, up to Valenzuela to Bislig, which is 8X sub 15. This is exactly the same as how the professor also um, modeled the transshipment problem that was presented in the video. But in my example, there is an additional constraint, which is the shipping between shops or shipping between the demands. So we have from Surigao to Butuan to Surigao, so that's 3x sub 16. Then Surigao to Butuan is 3 times x sub 17. Then Butuan to Bislig is 5x 18. And lastly, from Bislig to Butuan, 5 times x sub 19. Now, the company would like to minimize the shipping cost, so we have to minimize this um, total cost. Next, we have to identify the constraints of the transshipment problem. So as the professor said, there will be one constraint for every node. So meaning, yes, one constraint for every point. So let's start with the manufacturers. So manufacturer Yi can produce 1,800 1,080, meaning this at this point it can ship 1,080 linens to Malabon, Muntinlupa, and Valenzuela, and these are represented by variables x sub 1, x sub 2, x sub 3. So the sum of the three must be less than or equal to 1,080. That's for node Yiwu, followed by node Guangzhou. So the sum of the linen shipped from Guangzhou to Malabon, Muntinlupa, and Valenzuela, that's x sub 4 plus x sub 5 plus x sub 16, must be less than or equal to 1,100, which is the capacity of manufacturer Guangzhou. Then we proceed to the points representing the shops. So, according to Professor Aman, customers only need the exact number of product that they ordered. They do not want less. So if they will order 980, so dapat 980 gyud ang madawatan, not less, not more, or not less. So for Node Butuan, we have uh, shipments from Malabon, Muntinlupa, and Valenzuela. So that's represented by X sub 7, X sub 10, and X sub 13. Minus X sub 16, which is the number of linen shipped from Butuan to Surigao. Then for this arrow, that's X sub 17, that's Surigao to Butuan. So it's going to Butuan, so plus X sub 17. And then for this arrow, Butuan to Bislig, so that's minus x sub 18. And finally, for this arrow, Bislig to Butuan, that's plus x sub 19. So linens are coming into Butuan. Then for node Surigao, so from the three, there will be linen shipped from the three warehouses. So that's X8, X11, X14. And there are also linen shipped from Butuan to Surigao, so that's X sub 16. And coming out from Surigao, X sub 17. That's why it's minus X sub 17. And the remaining product in Surigao must be exactly 650. That's why this is equal to 650. Next for Bislig, we do the same. So we got this constraint. Three more constraints for the warehouses Malabon, Muntinlupa, and Valenzuela. So I would like to repeat what the professor said. In the warehouses, no products must be left. Everything that is shipped to the warehouse must be shipped to the customers. So in other words, the inflow minus the outflow must be equal to 0. So for node Malabon, we have shipments from Yiwu and Guangzhou. That's X1 plus X4. And there will be linens to be shipped out from Malabon. So that's going to be minus X sub 7, minus X sub 8, and minus X sub 9. And the total must be 0, meaning no linens will be left in the warehouses. In the same manner, we can also form the last two constraints, the constraint for node Muntinlupa and the constraint for node Valenzuela. So with these constraints, we can now input this in 6PAP. So we got our answer. So the optimal cost or the minimum cost, the least possible cost to ship the needed linens from the manufacturers is 40,180, and these are the values of our X sub i's, or these are the number of linens that are shipped from a particular point to another. So I also inputted this now in Excel, since I will be using Excel solver to explore the sensitivity of this model. So as you can see, we got the same answer comparing the two from 6PAP and from Excel solver. So the optimum solution is 40,180. It's the same. And the values of the X sub i's, as you can see, is also the same using 6PAP and Excel. So let us now look at the flow of the product based on the optimum solution and the optimum cost. So X sub 1 is 0, so no linen will be shipped from Yiwu to Malabon, but there will be linens to be shipped from Yiwu to Muntinlupa. That's representing X sub 2, which is 550. Then we also have from Yiwu to Valenzuela, then Malabon to Butuan, that's 980, that's X sub 7. X sub 8 is 100. X sub 11 is 550, and X sub 15, 530. So as you can see, all the required linens by the shop are shipped from the warehouses. That's 980. 900 for shop Butuan. It's 980. For shop Surigao, it's 100 plus 550. That's a total of 650. And for shop in Bislig, exactly 530. So the answer to our problem is the optimal cost, or the least cost of shipping the required linens to the shop, is 40,180 pesos. So I will now go to the sensitivity analysis of the problem if there are no questions. But before that, I will be sharing my Excel file, so you will see, we can explore the changes in the objective functions and the right-hand side of the constraints. Excel for a while. Okay, sir, makita niyo mo akong Excel, sir?
Okay ra, okay ra.
So first, we input the numerical coefficients, or the coefficients of the objective function. So I also copied the LP problem here in the Excel. So first, we input the coefficients of the objective function. That's what you can see in Excel 4. Then we input also the coefficients of the constraints. So that's what we can see in row 5 to 12. Here in this column B, are the right-hand sides of the constraints. So you have 1080, 1100, 980, 650, 530, and 000. Okay. Then here in this column U, we have the cost. So if you will look at the the formula in this particular cell, this is the sum product of this row, which is the number of linens, or these are the values of the X sub i's, times the values of this row. So many of us already know this. In the same manner, we compute the values of the left-hand side of the constraints. Then we solve the optimal solution. So we go to data, solver, then leave the objective as it is, since we have already clicked the total cost, then click minimum. This one is this row, the values of x sub i's, and we input here the constraints of the problem. Then choose simplex LP, then solve, and we will include the answer, the sensitivity, and the dinanta na limits. Akala lang, answer and the sensitivity. So first, I will show to you the answer. Wait, entire screen na lang po for a while, sir. Makita pa ni makong screen, sir? Kana.
Karon wala na.
Kana, sir.
Kana.
Sige.
Kana na.
Sige, sir. So, in Excel, pag run atong solver, it will also give us a separate sheet for the answer report. So, muna siyang answer report, which I also copied in my PowerPoint presentation. So, in the answer report, I will be sharing with you two tables. The first table represents the optimal objective function value. So, as you can see, the final value is 40,180. So, ato nang nakita ganihan no, using 6pack and Excel. Then, for the second table, this represents the optimal solution. So we can also see the values of, or the number of linens that are shipped from one point to another. So since in my table, I named a row, or I allocated a row for the destination, say Yiwu to Malabon, Yiwu to Muntinlupa, that's why it also reflected here in our answer report, that the number of linens from Yiwu to Malabon is 0, number of linens from Yiwu to Muntinlupa is 550, and so on. Now, in the second table, which is the sensitivity report, okay, this table, so na-present po ni Sir Glenn last time, but I think it will have a different interpretation since they also presented a different problem. So in the first table of the sensitivity report, you can see here a column for the final value. This is exactly the same values as I have shown in the answer report. The one in the slide, this one, final value. So duplicate, no. This one. So duplicate lang na siya, na diring apart. Then the reduced cost, we also have the objective function. The objective function are exactly the values or the coefficients of the objective function. So aning problem, in this problem, the coefficients are written here. So coefficients are its objective functions, and these are the allowable increase and the allowable decrease in the objective coefficient. In other words, if we will go out from this, or we will exceed these allowable changes in the objective coefficient, there will be an effect in the final value, and of course an effect in the total cost. So if you are given the allowable decrease, so in other words, we can compute the lower limit. The lower limit where the values of the objective function can run from and to, from 1 and 2. So bali, for this row, the lower limit is the objective function minus the allowable decrease. The same way we can solve the rest of the lower limit. And for the upper limit, that is equal to the original objective coefficient plus the allowable increase. Okay, that's it. So, ano siya? So, mabalik ko sa ako ang PowerPoint, so you will see atong gitapad sa atong Excel, so we will see how the data changes if we exceed or mulapas ta sa ato ang limits. So for example, ako lang itapad. Ay, sorry. So say for example, no, let's focus on the linens shipped from Guangzhou to Malabon. So according to the sensitivity report, the objective function can only, it can change, no, whatever we want, but for the final value or the values of x sub I to not change, or the only possible values for the objective function, so that the solutions and the optimal solutions and the optimal cost will not change, should be within the limit. So meaning, this objective coefficient 10, ang iyang allowable change must be within 10 to 14. If it will stay within the limits, then there will be no changes in the values of x sub i's. But if it will go out of this limit, example mo 15 na siya or mo 9 na siya, so maapektuhan na ang ato ang optimal solution. So let us illustrate that. This is E3, no? So kung atong i-change ang objective coefficient to 12, note that 12 is within the allowable limits. So let us see. Example, instead nga 10, tama ba? Instead nga 10, let's make this one 12. And let us run again our solver. So, okay. So as you can see, wala na change ang value sa ato ang x sub i's, meaning no changes in the number of linen shipped from one point to another. Now let us try if we will change the coefficient of this particular of this one to 15. 15 ba to? Allowable is 10 to 14. So if we will make this 15, then run again the solver. Okay, so as you can see, na-change siya, no? Wala na ni siya dire. I-compare sa ato ang final value. The value is 0, 550, 530. This should be 1,080. This time, nahima siyang 0. So, let's write this back to its original. Lost. So E sub 3 must be 10. So that is what it means on this allowable increase and decrease. For the reduced cost, this means that if we will reduce the objective coefficient, objective coefficient minus the reduced cost, the final value 0 will be changed. Example, let me illustrate this part. This is G3. So according to the report, if I will read by 5, so meaning I will make the objective coefficient 10 instead of 15, the number of linens shipped from Guangzhou to Valenzuela will be changed from 0 to a positive number. So let us do that. So instead of 15, we change this to 10. And as you can see, originally, no linen is shipped from Guangzhou to Valenzuela. But now, reducing it by 5, based on the reduced cost, if we will run again the solver, okay. So, na-change na ang ato ang Guangzhou to Valenzuela. So, na siya gi-ship nga 100. So, let me return that to 15. So, that's the meaning of the allowable increase and allowable decrease. And the interpretation of the reduced cost. Now, let me proceed to the second table in the sensitivity report where you can see again the final values. Final values, actually, these are the right-hand side, constraints of the right-hand side of the constraints. This one is the final value. Again, the final value are the number of linens shipped now based on the optimal solution. The, the third column is the constraint of the right-hand side of the problem. These are the right-hand sides. Now, as you can see, there is also a column for allowable increase and allowable decrease. So this means that we can also form limits for the changes in the right-hand side. So, bali the demands, we can tweak the demands from the shops according to this allowable increase and decrease. If we will stay, or if the change stays within the allowed limit, there will be no changes in the final values, which are the number of linen shipped to the shops. So for example, let me go to the slide. Example, let's take a look at the first constraint. The right-hand side is 1080. We can see that here. X sub 1 plus X sub 2 plus X sub 3 less than or equal to 1080. It's here 1080. According to the sensitivity report, if we will change the demand, or we will change the right-hand side of the constraint so that it is still within the limit, there will be no changes in the values of X sub i's. So if we will do that, as you can see, the lower limit is 1060. The upper limit is 1180. If I will change that to 1100, that's within the limit, it will not make any changes. Let's see. Let's run again the solver. Na-change ba? No. Wala na change ang ato ang optimal solution. It's still 40,180. Now, what happens if we will, what does it mean when you say there is an 18 shadow price? So, this 18, kanina lang akong i-illustrate. This 20 shadow price means that if we will change the right-hand side so that it is within the allowed limits, then we can compute the new profit without computing it using the solver. How do we do that? So say for example, we will change the right hand constraint, the right side of this constraint to 600. That's within the limit. So the profit will now be the new range is 650 times 20. This 20 is the shadow. Change the right hand side. So let's show this. I hope wala nga palpak siya. So 1080, I'll just write this back. This is 1080, this is 1100, 980, 650, 530, then 00. So again, from 650, I will change it to 600, which is still within the limit. Our expectation is that the total cost So our expectation is this will now become 39,180. If, again, I will change the 650 to 600. So let's see kung nabalik na ko tanan ang cost na ako na-review. 12, 8, 10, 10, 12, 15, 8, 10, 12, 10, 12, 12, 12, 15, 8, 3, 3, 5, 5. Okay. So let's run again. Again, we are expecting expecting based on the shadow price that we will get 39,180. That's the least cost, 40,180 minus 1,000. Tama, no? Sige, so let's solve. Okay, so we got the same answer, 39,180. So in the same manner na, if we will try to change this to 669, this 650, again, it's still within the limit. So we can compute the changes in the profit. So that's the new right-hand side minus the original right-hand side times 20. 20 is the shadow price, so that's 380. Meaning there will be an increase of 380 pesos from the original total cost. So let's try that. The original was 48,000, 48,100, 40,108. 40,000, let's say 40,000 for 180. New 40,560. If we will change 669. So we got the same result, 40,560. So in other words, if we have the sensitivity report and we have a column for shadow price, we use the shadow price to compute the new cost when we change the right-hand side of the price. So this is the end of my presentation, and these are the references that I used to prepare this report and the videos that I used in my transshipment model. So that's the end of my report, sir. Thank you and good evening.
Wow, that's another very good presentation, no? Associated with transshipment problem. And as I said, there are so many models that can be presented using the transshipment problem. You can really have different models, and even a network model still associated with the transshipment problem. So if Ms. Impuesto was able to discuss a transshipment problem, that's just one model. You can still discuss transshipment problem for another model using different model, different from what Ms. Impuesto has discussed. So no problem, you can still present transshipment problem. Pero lahi na pod nga model, no? Lahi na pod. Daghan na klase. Okay? Daghan na klase. So, napabatay time. Gamay naman lang. Any question from the discussion? That's already a very good discussion. That's why using software is very important to this discussion we have. Karon di ta malubong sa computation, no? Kaya kung i-compute to na panagiingon nga abtan tag siyam-siyam, di ta kaabot ani nga mga discussions nato kung mag-compute pa ta manually. So we need the software to aid us for the computations as we advance our topic to, shall we say, transshipment problems, to network problems, other than the transshipment problems. Okay. Where is Michael? Ano mas Michael? Naka-record pa ba ni? Still recording? I think Michael has left the meeting. Anyway, I recorded it here in my computer. I just do not know the output of this. Let us see after this discussion if I got the correct recording of this discussion. Wa pa na ko matistingi, manggod ni. Yung akong record dire. Atong kas-an, kuan man ni na sipiat man ko. Wa may na-record. Tanaw na po na ko ni ron. Any question? We will discuss next meeting. Ato si ihatag kang kuan. Panas Michael, no? How about Nimenyo, Nestor? Can you discuss next meeting?
Sir, nakoy travel next meeting, sir.
Naka-travel.
Next week, sir.
Si Rojon. How about Rojon? Pag mo tingog, okay siya ni si Rojon? Rojon? Are you prepared to discuss next meeting? Wa man. Tubag. Naka-mute man mo. Si Patricia ka. How about you, Patricia? Can you discuss next meeting? Asa naman yung mga tao diri nangawala man. Video naman siguro yung nagpabili nila ani diri. Hello?
Ma'am Id, sir.
Sir, sir, bilis ako, sir. Nag-process ako sa result, sa report today. Hindi lang sa ako, sir.
Okay, Rojon. Anas Rojon. Laman. Elvan. How about Elvan? Wag yapon. Si Rolino. I-discuss din si Rolino next meeting. Hello? Wa na may tao ni. Nangawala naman eh. November na lang kuno si Elvan. Si Rolino. Rolino. Or si John Mertel. Napa si John? Isa man yung 5 others dire. There are still 5 others. Di man ko ka basag kinsa ni. Dabe. 5 others. How about Romeo? Neo, are you ready to discuss?
Hello sir, good evening sir.
Oo.
November na ko sir,
Ano
kaya
ba?
prepare po sa akong midterm exam.
Wala, nagdasok
Oo,
na mo
prepare po ko
November
sir.
ba? Kuan ra ba? In November 1 to 5, asa to? October. Di. Naarabay 1 week break diha. So, di ta pwede mo magklase-klase anang kuan. Academic break. Apil po ta diha sa academic break. Mga 1 week. So, mawala na ng murag mga 2 meetings na to na ba? Mawala. Tanaw na to. O ma-exempt ba ta na? Kung dili na maghuot na ta ni. Na ay one week academic break after the midterm examination, which I think is sa kalimot mo ko. Basta kay murag December 1 to 5 to academic break. Na kuan man na usab ang schedule. Kana murag makaambak ta ni next year o dili na to ni masunod-sunod ang discuss. Si Evelyn. Evelyn? November na pod.
Patudlo pa mi sir.
Naurot naman mo November. Oy, Manuel. Pasig na
Ngita kami
Ito
problem
ni
sir.
isa-isahon be kaya ron nga. Dili good as detailed as
Evening, sir.
what Chen has discussed. Emmanuel, okay ka? Next meeting. Ito yan mo.
Tanaon lang, sir. Actually, sir, murag kuan jud, murag malumos pa ko sa kuan. Sa concepts. Pero ambot lang, sir.
Atong kang
Tingan, sir.
Gretchen, detalyado gid kayo to. Bisag dili good ingon adto, no? Katong iya discuss na gyud niya ang tanan na gyud nga possibility sa sensitivity analysis associated with the problem that she has discussed. Even not like that, no? I just would like you to make some changes in the model that you can come up based from the model that you have chosen from YouTube video associated with network problem or transshipment problem. So, mag-apply lang mo og sensitivity analysis, makaduha ka tulo to come up with 3 different models, something like that. Not necessarily that you have to discuss all the possibilities that can happen, just like what Gretchen has discussed. Kay yan naman yung gipakita nga pag mo taman ra ka 80, dili ka mo lapas paubos sa 20, okay ra ang final value. So kato all possibilities naman nga nahitabo sa mao nga problem ko. Kanang inyo muraga trial and error lang, okay naman po na trial and error lang kay shall we say testing man lang po ta sa sensitivity analysis. But if you can discuss the details, okay, all the possibilities that can happen to the model that you have constructed, mas man to, the better. Si John Mertel, basi maka-discuss next meeting. John, okay ka? Next meeting ka? Naman to. Ano ra? Ready na ka dyan? Next meeting, ikaw daw. Di ko kay detalyado ang ato raman nga naakay na napilian sa YouTube video. Okay. Basta associated with network problems, with transshipment problem, ana lang tahay, no? Then you construct your own model based from that model you have found from YouTube video. Then from the model that you construct or you constructed, you apply sensitivity analysis by just trial and error to come up with another 2 or 3 different models. Okay? So, upat na tanan imong model. Tulo, upat na tanan imong models. Then, compute. Because each one has an LP model, LP problem. So, compute using the software. Then, discuss. Kaya naman yun na yung mga diferensya tahay. Kung swertehon ka, naman yun na yung pinakagamay. Basta possible lang, no? With respect to real life situation, posible lang yun siya. Dili siya out of this world ng mga discussion sa imong model. Okay naman na. Ang ato lang makadiscuss ka ba? Madiscuss nimo ang imong gitrabaho. O madiscuss nimo imong gitrabaho niya. Na kay napilian sa imong pag-trial and error, tulo na kabuk yung model, nakapili kag isa nga mas maayo. Okay na gud. Ana ra gud. Pero kay kuan lang ang imong na-construct nga model based from sa YouTube video nga imong nakuha nga model. Kinahanglan nga gi-applyan nimo kaugalingon na nimo karon nga ideya. So kadto nagisgot og mga eroplano ana karon imo gusto nimo magnegosyo lang ka og mga saging-saging dire. Oh. So saging na pud imong gipamutang dire. Ya, siyempre lahi na po nag-value kay mahal man to eroplano, brato man ng saging. So lahi na po to value. Ya, Pilipinas naman So piso-piso. Ana. Ay na to mga pounds kay imo na gani ning style dire. Ang imong sa YouTube pounds o dollar. Ini imo dire piso-piso na kay Pilipinas naman ta. Imo naman gi-apply. Ana lang gud. Ato lang makabalo na ka mo apply o mo nakahimo gyud kag imo ba nga bisag ipang-ilisan lang nimo ang variables, ipang-ilisan ang mga prices dito, ang mga expenses. Basta kay nahimo na gyud nimong imo na siya nga construction sa model. Okay? Sana tong Jan, pinawala si Jan noon. Wala si Jan Mertal. Mission Sal. Mo join po kaniha mo himo po kag imo kay part man ni sa kuan kining oral na to nga exam. Okay? This is now an oral exam. Okay, so basi mapangutanan nimo Miss Gretchen kung makadiscuss ba siya next meeting. Okay, putol-putol man nya murag kamo man makakonek. Miss Yonsal, so pag-apil po ani kay duha ra man baya gyud ang atong exams ani. Oral exam o written exam. So duha ra ka exams gyud. Kani galing lang kay nanatay kwan atong miagi kining oral man pud to. Pwede man gud to himuon akong quiz kung unsa so quiz to siya nga oral. Kini final exam nga oral. O ana ra gud na. O kaha kutong i-collect tanan mausa sila as an oral exam. Pero kini dako-dako naman ato na lang nimo nga oral exam na lang ni siya nya kadtong isa nga kadtong previous sa inyong discussion sa simplex algorithm mo na lang nato tong quiz nga oral. O, di na natay quiz. Atay quiz dito. Basta kay duha ra ni kalinyahan ang ato, isa oral, isa compre. Compre ning written exam. Lahi ko itong mga activities gyud. Okay? Ina, kisay makapaniguro next meeting, oy. Sayang atong panahon. Si Manuel na, murag. Kaya ba to? Ikaw ba to, Manuel? Next meeting, kaya? Karon nga di ta magdasok sa November o December.
Tanaw lang, sir.
Ha? Ay na tanawa, planuhan na. Man ron, Huwebes. So, Lunes, layo pa kayo. Ay, Huwebes, Biyernes, Sabado, Domingo. Napag kayo, 3 days. Kaya? Kinala dito mabakante lagi. Kaya natanaw na ko, marag di na tani binhawa na po daning kuan makalukso tani 2023. Okay, so tanawon ko no ni Emmanuel next meeting. So, atong tanawon. Mag-discuss na lagi na siya. Okay, any question? So, kung wala na, so bye-bye.
Thank you, Sir
See you
Joe.
next meeting.
Thank you, sir.
Sir Joe.
Thank you.
Sir.
Bye.
Congrats,
Thank you,
Ma'am
sir.
Gretch.
Thank you, Sir Joe.
Okay, Ma'am Amy.
Congrats,
Bye.
Ma'am Gretch.
Bye-bye. Manuel, next meeting. Ay, maipitas panahon.
Tara na, sir.
Go, Sir Iman. Go, Sir Iman.
Mandragon, kining mura gani kang nagpulig variable X, pulihan og variable Y. Ana raman gud na gud halos. Sige, bye-bye.
Thank you, Sir. Bye-bye.
Saan naman eh.
Mag-up nga kita ni, si Ma'am Evelyn.
Si Rom. Wajud ko. Bye.
Patayin sa amo ni. Bye-bye.